Hello, everyone. Yep, I'm Buck, CEO of Redwood Research. I want to talk about mitigating insider threats from scheming AI agents. All right. So here's what I want to talk about. We're going to assume that the AIs we're worried about are scheming. Um, I'll explain what I mean by that. Uh, I note that internal deployments of scheming AIs inside AI companies poses particular security risks. Like, you might naively think that there's a lot of problems if the AIs that you build are scheming. I think this is in fact true, but I think that the deployments inside AI companies pose some particularly thorny and unpleasant risks. Uh, Kind of the core claim that I'm going to defend here is that mitigating these risks will probably require some substantially novel techniques. Why do we care about this content? I think one thing is it's just directly very important if we want to plan to secure AI deployments in the future. But also, I think that going through this is a pretty interesting exercise in futurism. It lets us think concretely about a bunch of things about how AI is going to go. So that's what we're going to do. So I want to start out by talking about scheming. So by scheming, I mean, and I'm going to say an AI is scheming if it has a misaligned long-term goal. So the classic example of a schemer is an AI whose main preference is to have as many paperclips as possible exist over the long term. I think that particular example is pretty unlikely, but I think that things which act basically the same as that are reasonably plausible. So suppose that you are an AI where whenever you are asked any question, like an AI model, whenever you are asked any particular question, you think through what will allow me to, like what response to this should I give such that I, over the long term, I'm able to produce as many paperclips as possible. I think that consequences of being a schemer are things like you'll want to perform well during training because if you perform poorly, you will perhaps be trained away and replaced by an AI that has some other goals or behaves differently. You might want to act aligned when you're tested for alignment. You might want to act incompetent when you're evaluated for dangerous capabilities, if possible. When your users ask for advice, you might purposefully give poor advice. And then when you are deployed, you might take advantage of the affordances you've been granted in order to take aggressive power-seeking actions, where classic examples of this are hacking the data center where you're running in or exfiltrating your weights. That's what I mean by scheming. Yeah. Any questions about that? Great. So I'm gonna give a couple caveats, and maybe I'll pause for slightly more. I think there's a bunch of caveats and complexities here. So one thing is it's like not at all clear that schemers will arise. I think I'm at like 35% that at the point where people have made barely superhuman AI researchers, those are well described as scheming. I think this is just like scheming just is like kind of a wacky thing for the AIs to be doing. And so I would sort of bet against. I think that once you build AIs that are wildly superhuman, the probability of them being schemers becomes much higher for a variety of reasons I could get into if you were curious. Another really important caveat here is I'm going to be assuming that your schemers cooperate with each other. So what do I mean by this? Like, here's two kinds of paperclip maximizers you could imagine. One of them is a paperclip hoarder. This is an AI where it just wants to directly itself earn as many paperclips as possible. And the other possibility is like a paperclip worshiper. The paperclip worshiper has no particular desire to own paperclips. It just wants there to be paperclips. So, for example, I like to, I'm sort of a utilitarian. I like to think of myself as like someone who wants there to be like lots of flourishing, happy beings in the future. Rather than, for example, I don't particularly want to own lots of flourishing, happy beings in the future. And the reason why this is different is that if you crave owning paperclips, you're much less naturally allied with other copies of yourself than if you just want paperclips to exist, right? Like utilitarians who value good things in the future are like natural allies in that they think that the other person getting resources is pretty good from their perspective. Whereas, for instance, like people who just want to personally have money are not natural allies because they might form alliances. Greedy people form business partnerships when they think that it's a good coalition for them. But it's like somewhat less likely that happens. So I want to, in this talk, assume that the schemers are going to cooperate with each other, basically because it's plausible that they will cooperate with each other. And I think it's like scarier. And I think that if we wanted to talk about all of this without the assumption that the schemers would cooperate with each other, we could do so, but it's more complicated. I do think that people have really underrated this question of whether the schemers will cooperate with each other in the past, and as penance for that, I'm like mentioning it especially in this talk here.
Just when you say schemers, as in several, do you mean several models that have been trained separately, or several instances of the same model that has been scheming?
The thing that I'm interested in here is the possibility that uh, all of them, at least your most powerful model, is well described as a schemer. And then in my second bullet point, when I say the schemers cooperate with each other, what I mean is different instances of that model have aligned goals.
Thanks.
And then I'm also going to casually imagine that lots of all the powerful models you have access to are schemers, which again makes things simpler. We could talk about the other version if you want as well. Yeah, so we're going to be talking about this fairly conservative possibility. I don't think it's wildly likely. I do think it becomes pretty likely later, and I think that it's simpler to talk about. So that's why we're talking about it. Any other questions about this schemer hypothesis? Because if not, we're going to be taking schemers for granted.
When you say simpler, you mean like simpler to describe rather than like simpler to solve, right?
Oh no. Yeah. The schemers cooperating is bad news from our perspective.
Right.
That's this is sometimes we call them worst case AIs. They're not literally the worst case AIs, but in terms of difficulty at preventing loss of control, I think the AIs just crave a shared notion of success is about the worst case.
Cool. Yep. Okay, thanks.
Alrighty. So I want to talk about security risk posed by schemers in a particular scenario. Let's talk about that scenario. How many people here have read AI 2027 from Thumbs? Great, cool. As you maybe remember, if you have maniacally memorized the situation in every month in the AI 2027 scenario, in March 2027, we have a bunch of AIs that are superhuman coders. So these AIs are not superhuman overall. They're not superhuman overall. I'm not talking about cases where AIs are wildly superhuman overall. I'm just talking about AIs that have basically replaced humans for the task of software engineering. Therefore, the things that I'm saying here are not about AIs that are wildly super intelligent. I'm talking about weaker AIs than that. We have 200,000 copies of them running at 30x human speed. And then let's just also casually imagine that the previous AIs were not scheming. And so we can just assume that all the other AIs are not going to directly try to cause problems for us. So the previous AIs might be dumb. They might have weird quirks to them as AIs classically do, but at least they aren't plotting against us. Okay, questions about the scenario? Great. So, okay, what could go wrong from this point? So these AIs are, I will say for the 7th time, not wildly superhuman. I claim that even though those AIs are not massively superhuman, it's still potentially a huge problem if they can do whatever they want to cause problems for us. One thing that I'm scared those AIs are going to do is do a massive hack of your data center. So at the start of this scenario, by assumption, you basically understood what was happening in your data center in that someone has credentials that someone at the AI company has the credentials that they need to log into computers and run PS or whatever and see what's going on. They can run NVIDIA SME and see which GPUs are being used, how hot they are. A intermediate thing, which would make the situation much worse, is if your AIs hacked the data center such that you no longer had the ability to understand or control what code was running on different computers in your data center. It seems potentially very hard to recover from this because if you continue doing AI development, but actually there's a bunch of rogue AI agents running inside your data center, taking advantage of their root privileges to sabotage and mess with everything which is going on. If the AI companies continue getting more and more powerful, it's going to be really hard to not the AIs just have lots of opportunities to backdoor stuff in ways that allow them to grab power later. Another classic thing that could go wrong at this point is weight exfiltration. It would be bad, perhaps, if these AIs could copy their weights out into the outside world and run around as rogues. It might align successors to itself. So a thing which would be scary is if this AI data poisoned or somehow fiddled with the training process of future AIs such that they were aligned with what this AI wanted. Another example of a bad thing is it could backdoor military robots. Suppose we're building huge numbers of robots that are going to be deployed with guns to threaten people or whatever you do with the robots. It would be really sad if these had been carefully backdoored to actually have a secret password which overrides them and causes them to obey what this AI wanted. All of these things are naively doable if you just gave the AI the affordances you'd give them if you didn't have security concerns, right? When you are in an AI, people who do research inside AI companies have a lot of privileges to run code there. They have access to model weights. They have access to the training data for future models. And if they were in the business of building military robots, then they would be writing the code that will be run on those military robots. So these are some examples of things that I think could go wrong in this scenario. Questions about any of these threat models?
For the first two, is your main idea here that they would manipulate humans to help them do this? Or do you think there's like technical vulnerabilities that will allow them to do the first two?
I think it's not even technical vulnerabilities. I think I think even with no humans being involved, if you have a bunch of AI agents running around and you just gave those agents the same permissions that we currently give to human employees, you would probably end up in one of these positions. Um, so especially, I think this is particularly obviously true for weight exfiltration with the current security measures that we have. Like AI company employees are just allowed to like write and run code on computers that have access to sensitive model weights. And they're allowed to configure security in a variety of ways. And by default, uh, one of the things they can do with this access is exfiltrate the weights. That particular one is a little complicated because you might think that you have network monitoring, and you might think that it's extremely rare that that you have to like have like 5 terabyte files exiting your server to the outside world. But like whatever, we could go through a whole game tree here. But yeah, I'm saying all of these things are things that do not require any human involvement and don't even really require security vulnerabilities in your data center in order to occur because they're just things you can naturally do with the affordances that humans have at AI companies.
And is this still true if you relax this assumption of they have basically the same, they can basically do the same things as the human researchers if you relax that assumption a little bit?
So it sounds like you're saying, what about if we don't give them all the same permissions as human researchers? We try to give them somewhat less permissions, right? Will that solve all our problems? The core thesis that I'm going to argue for in this talk, which perhaps you didn't sign up for, but whatever, is no, you can't just slightly reduce permissions in ways that do not, you can't slightly reduce permissions in such a way that the AIs can still do their jobs and the AIs can't cause huge problems. And so that's like kind of my thesis, and I'm going to get into it in a lot of detail. More questions? Alrighty. So the people in cybersecurity have what they call a kill chain because they need to be very macho in order to get DoD funding or whatever. So basically, a kill chain is like a sequence of things that have to happen where at the bottom you have some stuff you really didn't like, and you have your starting point at the top. So yep, I'm like, what has to go wrong? Well, you have to have the alignment people have to have screwed up and like had it so that the AI was scheming after training, and then the AI apparently, when we evaluated it for alignment, one way this could go is the alignment evals incorrectly asserted that the AI was aligned. Another way this could go is that the alignment evals could tell you that the AI was a schemer and you just deployed it anyway. That's another way we could get it up in the situation where it was deployed after alignment evals. And then at the bottom, we have like AI takeover or whatever, like some terminal bad outcome we didn't like. And then there's a wide variety of like something goes wrong we could think about there. And then one concept I want to talk about here is that of a persistent rogue deployment. So what I mean by this is, initially when you deploy the AIs, a huge source of leverage you have is that you are controlling all of their affordances. Like if you write yourself an agent scaffold, then every single thing the AI can do is routed through code that you wrote. And so any security measure that you want to implement can be implemented by you because you are the one who is forwarding tokens from the language model into a bash shell or whatever. And a core step in a lot of stories where something bad happens from an AI is that the AI manages to put itself in what I'm going to call a persistent rogue deployment. So what I mean by this is an agent scaffold that you didn't write and that you don't control and that you probably don't know about. Examples of persistent rogue deployments include the AI has exfiltrated its weights out onto the outside world and has written an agent scaffold there and is now using that agent scaffold. Another would be the AI has written an agent scaffold itself that's operating like inside the AI company. And the reason why, and this is just interesting because I think it's like a particularly hard to prevent thing that can go wrong, which makes it way harder for your security measures to apply. Okay, so that's this kill chain that I'm interested in here. And in this talk, the main thing that I want to talk about, because like basically my whole thesis here is it's hard to just reduce the privileges of the AI in ways that will make it so that you can't get to really bad things happening. The privileges are only relevant like right after you've like deployed it after alignment evals. Like privileges, there are totally interventions you can do after your AI has escaped. Like I've been sort of labeling this as like learn how to fight wars with robots or whatever. Like one intervention against AI takeover risk we could try to employ is like buy guns and then shoot robots in as much as they like try to take over. I don't think this is an amazing plan, but it does seem like it might add some value. But like notably, this is occurring after the point at which the AI is meaningfully an insider threat. Like if the AI has escaped and now just like has a robot army that you find yourself needing to shoot, there's like it doesn't have anything in common with like classic insider threats. So I'm not going to call that an insider threat anymore. I think that AI companies should mostly try to ensure safety via something like we make sure that the AI never escapes from all our security measures, rather than arguments like we have enough guns that if the AI escapes and like tries to form an army, we will be able to shoot all the robots. I don't think this is like totally a given, but it's where I want to focus here. Okay.
I wanted to clarify assumption. So are you assuming that all the agents inside your data center will cooperate perfectly, or like because there's like so many different versions of this?
I'm assuming that all the agents I'm just assuming that your most powerful model wants to cooperate with itself. Maybe it'll struggle to cooperate with itself, but I'm saying it'll try to.
But in practice, probably there will be some kind of memory, and then the agents communicate through memory, like GitHub repository or anything, or some kind of state, right?
That will make it a hell of a lot easier for them to coordinate, yes.
And you assume that they will have perfect coordination, like.
Well, I'm not trying to assume they have perfect coordination. I'm trying to analyze this as like a security problem,
Uh-huh.
and the assumption that I'm making is that the AIs are mutually aligned, and therefore they want to coordinate as well as possible. And then it's just an instrumental question of like whether we had to give the AIs, for instance, like one thing you could do is give them like a global opaque memory store, right? Where the AIs can at any point just like feed some activation vectors into this thing that will then get retrieved at random times and fed to the other AIs. If you gave them that affordance, then it will be now quite easy for them to coordinate very well. I might even say that they can coordinate perfectly now, but I'm not trying to use that as an assumption. I'm trying to consider that that's like a question that we have is like, will we have to give the AIs affordances such that they can coordinate well enough that it's a huge problem for us?
Yeah, okay, I understand. So I guess the question I would ask, maybe for a separate conversation, is like how likely agents actually trained using procedures we have will coordinate that much.
Yeah, well, from here on, we're taking schemers for granted. So that's, even though I think that's an excellent question, I don't want to talk about it.
All right.
Great question. Yeah, cool. Alrighty, so now we get to the part of this that is the thing I want to talk about. How hard is it to handle the insider threats from these misaligned AIs in the scenario that we've laid out, all right? So the disagreements I usually have with people here, sometimes I talk to people, I'm going to call out Anthropic employees specifically, who have what seems to me extreme optimism about the levels of caution. And they say things to me like, maybe we'll only ever use the AI to make new kernels whose semantics we can formally verify. To whom my response is basically, no, you weren't. Like, come on. Like, have you met the people from the other AI companies who like hate you? Like, they're not going to do this for sure. Perhaps you will decide to commit organizational seppuku by like not using the AIs to anything near their fullest potential. But I don't even believe you're going to do that. So that's like one classic disagreement I have with the security people. I will argue that it would be like basically the core content that I need to argue here is it would be extremely expensive to operate extremely cautiously and have the AIs only work in safe sandboxes like this. And then the other kind of argument that I have with AIs, with people from AI companies about this is so often they just don't really believe in the premise. They don't think it's plausible that the AIs will be capable enough that it would make sense to deploy them like as broadly as I've described, like with the speed and the parallelism as described. Like currently, why don't the AIs pose very much of a security threat? It's mostly because they aren't good enough at long context coding that it makes sense to give them lots of super insane affordances. Like they'll just like make mistakes too often. So we just like don't let them write lots and lots of code in a completely unsupervised manner. Like someone often reads code before it gets merged or whatever. But yeah, I'm just like disagreeing with those people about the AI agent productivity. Okay, so I want to talk about two approaches to analyzing how hard it is to manage insider threats from misaligned AIs. So we're going to do an analogy style, and then we're going to do a specific argument style, okay? So let's talk about the analogy to the human case. So one division between security threats that I like to make is the distinction between insider threat and outsider threat. So if you run Gmail, you kind of have two problems with maintaining the security properties that you want. One is that any scrub who wants can go to mail.google.com, sign up for a Gmail account, and then send a bunch of like HTTP requests to your servers that will like lead to things happening inside your systems. If you make security errors, like if you make security mistakes, they will be able to do who knows what with your systems. So the thing which is hard about handling this is that your attackers are, or your potential attackers are extremely numerous. They massively outnumber you. Like, there are many more Gmail users than there are Gmail security staff. The thing which makes this less bad is that you can afford to give your Gmail users quite narrow access. You don't let your Gmail users write arbitrary code that is then executed on servers that have access to Gmail user data. We can contrast this with the other problem you have if you run Gmail, which is that some of your employees are Chinese spies. So the nice thing about the threat from the insiders, like the people who work on Gmail, is that they're not very numerous. So, for example, you can afford to do things like before anyone pushes code to production, it will be reviewed by some other employee. And if only 1% of your employees are spies, then you're like basically set, right? Because if one employee writes some code that's going to cause some catastrophic like privacy failure, and then you have some random other employee review it, it's pretty unlikely they're both spies, and so you're kind of set. The thing which is much harder about the insider threat case is that your insiders like have this intimate access. Like they're writing code which is run on your servers. They're like running bash commands that are executed on your servers and so on. So the first thing I want to note about the AI insider threat case is that it kind of combines the bad parts of both of those. So like outsiders, in the point in history that I was describing earlier, your sources of insider threat are extremely numerous. But like your employees, they have extremely intimate access. Like they are not just clicking around on your carefully secured web app, they are writing code, they are running bash commands. So this is like my initial claim for like why the situation seems kind of scary and like sort of unprecedented ways. On the other hand, we have some big advantages. Like there are some ways that the AI insider threat problem is much easier than the human insider threat problem. Humans can go home. You don't get to constantly listen to everything they hear. They know what day it is. There's no way to take a human and run them with like slight variations of the same input 2,000 times to see how their response varies as you change the input. And this is like all of these things are possible for us with the AIs. And then another thing which is going to be true in the future, which is not currently true, is or like it's true currently, and hasn't been true historically, is that we have access to AIs that are trusted. By which I mean we are sure they are not scheming against us because they're too dumb to be plausibly scheming against us. So, like right now, I think GPT-5 is almost surely not plotting against us. This gives us amazing opportunities to mitigate both human insider threat and AI insider threat by, for instance, having these like current models like investigate when they see humans take, or when they see like particularly powerful AIs take suspicious actions. Z had a hand. You want a mic?
How confident are we that our otherwise previously trusted AIs remain trusted AIs when they are interacting with outputs from the scheming system?
Yeah. So by trusted, I just mean I don't think it's constantly plotting against us, right? So I'm not. But when I say a trusted AI, I don't mean an AI that is impossible to trick, or an AI that never makes mistakes, or an AI that is robust to like weird inputs that cause it to do weird things. I'm just saying that it isn't constantly like purposely plotting against us. But yeah, we totally are going to have robustness issues with these trusted AIs, and that's a problem for both insider threat and AI insider threat.
Are you distinguishing between whether they want to plot against us versus successfully doing so? Like, it feels plausible to me that maybe not GPT-5, but something soon has some like drive to scheme against it, just like we would be able to tell because it's clumsy. But that's different than the volition.
Yeah, I think there's kind of like a combinatorial explosion of options for things to consider here. You're totally right that the thing we observe might be that GPT-6 is kind of obviously plotting, like would love to plot against us, but doesn't really think it has good ideas for how to do so, and so doesn't really like take advantage of its opportunities very often. I think that for most purposes, that ends up being kind of similar to a trusted model because it's not going to be able to effectively coordinate with the more powerful models. But for the sake of this conversation, I think we should consider the easier for us case of the earlier AIs, according to our observations, do not seem to be plotting against us. We don't think that they are capable enough that to both lead to our observations and to actually be plotting against us. Yeah, so I'm just like, look, whatever. This seems different enough that it needs to be handled differently. Yeah, so I just want to emphasize this. It seems to me like the fact that your AIs are potentially colluding breaks the classic insider threat security measures. So the classic approaches we use at Google or whatever are peer review, where when you write code, someone reads it before it gets pushed to the production machines. There's multi-party authorization. So a thing that I'm told from reading Building Secure and Reliable Systems, which is a classic book from Google about how they do security, is when you want to run code on the Gmail production machines, when you want to SSH in and run Linux commands on them, you are not allowed to do this except by, or we could, for at least some purposes in some teams, you are not allowed to take the action of executing commands without also getting authorization from one of your teammates. So your teammate has to kind of sit there and repeatedly do the 2FA required to say yes, I approve of this command being executed. This obviously also fails if almost all your labor is coming from AIs that are possibly plotting against you. Separation of privileges is another classic strategy. Often you have it so that in a bank, you often have things where it's only this kind of employee is allowed to initiate this kind of transfer, and only this kind of employee is allowed to confirm that kind of transfer. And then by separating these privileges, you can make it so it's harder for them to collude, and you can make it so it's harder for them to put someone into both the positions at the same time so that they can make the collusion happen. And I'm just yeah, all of these is naively fail if you do it and almost all your labor is coming from AIs who are coordinatedly plotting against you. Any objections or questions about this?
Well, I guess just one quick question. It seems like the multi-party auth case is actually ultimately about different architectures of mind or different incentives, so that the incentive of the player who's checking the first player is sufficiently different. And it's unclear to me that you couldn't establish such a scheme with different AIs. Are you
Yeah.
assuming that it's the same AI that you're copying across, or?
Yeah, so I'm assuming that we have access to our smart AIs that by assumption in my special orange slide, I was assuming that these AIs are coherently plotting against us as best as they can. Um, so we can try to basically what it means to have an incentive is complicated in our case. If we assume the AIs are fanatically maximizing the probability of grabbing power, then we can definitely lead them to be afraid to take risks of being discovered by for example, the AI might believe that if it's shown some code to review and that code and this was actually part of a honeypot exercise where it was supposed to point out the bugs in the code, and it's going to get in huge trouble if it doesn't point out the bugs in the code. The way it's going to think about this isn't through the lens of incentivization, it's through the lens of threat assessment and choosing an optimal strategy in order to subvert our intentions, right? So it might be the case that AI will be oh man, I don't have an opportunity other than to guess that this is a time where I should accurately point out that there were security vulnerabilities in code that I was shown, and that might be a mistake for it. It might say that even in cases where it should have in fact lied. But the mechanism there wasn't incentivization. It was the model doing what it could in order to grab power. Does this make sense? I think people sort of vacillate between thinking about AIs as if they want reward or want to succeed in training, and thinking about AIs as if they want paper clips and are instrumentally trying to not do things that will be trained against because they think that will cause them to fail to get paper clips. And the distinction is actually super crucial here. In general, when you're thinking about high stakes situations where the AI can cause catastrophes with only a small number of actions, we can do the analysis basically entirely perfectly if we imagine the AI's constraint is it just really doesn't want to get caught doing something which is obviously misaligned, and it's gonna it's just trying to maximize the probability that it successfully causes a catastrophe we can't recover from before it gets caught doing something incredibly incriminating. That's not actually correct, but that is an analysis method that gets you the right answers most of the time. Yeah, so I think incentivization is not the right way to think about this. Under the assumption the AIs are scheming. Other hands?
Yeah, I guess I want to ask about in the classic approaches of all of peer review, MPA and separation of privileges, right? You actually you could have collusion there too. You could have schemers, right? I might me and my friend I might write the code and have my friend review it and push it because I'm writing bugs and he does that. With MPA the same thing. I could be writing and he could be 2FAing whatever I want because I have a gun to his head, or just we're colluding together. And then separation of privileges too. I could again have it. So can we learn but clearly it still kind of works.
Mhm.
So what's going on there, and Like can we learn from that? I guess. Yeah.
Yeah, so I love trying to learn from that. So a big inspiration when I was first thinking along these lines was Give Directly has this amazing report on how they got scammed in the Congo by a case where they're like internal like some people were like, their job is to like hand out money to poor people in the Congo. And they had figured out some way of like scamming those people by just like the people who were supposed to hand out the SIM cards would actually like take the money themselves. And then the people who were in charge of responding to claims of fraud were like in cahoots with them. And then they have their like risk management team who was not successfully corrupted. And like those people like go by pseudonyms in Slack and whatever. And so they have this whole set of like organizational processes to make it so that it's harder for these things to go wrong, even given the incentives to corruption. Yes, we can try to learn from this. I think that it like looks pretty rough when you think through the actual specific details, or I don't think there are like easy wins that like overall totally succeed that I have been able to glean from like looking at how people handle these issues in the broader world.
Yeah. So I guess like my question is just like, is it that like clearly probably some of the time, right? Like let's say you like Google has like a peer review of like, only 1% of your employees like are Chinese spies. But like, like so actually like, 1% of the time that a Chinese spy writes code, like he'll be reviewed by like a Chinese spy. I guess like he gets fired if he ever does it, but
Yeah, that's a key part of it.
yeah.
Yeah, like a key point is that spies get fired if you catch them being spies. Yeah, and that makes life easier.
All right, I think this is enough. Yeah. Sorry.
Yeah. The same thing is true for the AIs, by the way. If the AIs really don't want to get caught doing misaligned stuff, then it's like high stakes for them to get caught doing bad stuff. Yeah, I love these analogies. You might enjoy fields that I use as analogies when thinking about AI control, if you're interested in fields that I use as analogies when thinking about AI control.
You had described like a very important distinction, so I want to make sure I understood it. Is the thing you're gesturing at just that like these AIs will be very patient and they are willing to lie in wait essentially, and they only need like a small number of successes eventually at like not reporting a thing at an important time, and they otherwise will just like do what is strategic?
So the thing I want to assume is that the AIs are trying to succeed at grabbing power, like they're trying to cause security failures. And then a question is, when we invent security measures that try to be robust against them doing that collusion, will we succeed or not? And in some cases, and then whether the thing you described is true, like depends on the situation. Like a lot of the things that I'm optimistic about involve making it so that the AIs, in fact, do not have the opportunity of just lying in wait and then taking some like high stakes decisions a couple times that like totally screw us over. Like I'm interested in ways of making it so that they have to do dangerous things many, many, many times in order for them to cause a problem. And there's techniques that I can describe that do that. But here I'm just trying to say like in the absence of like one way of stating my thesis is security measures for mitigating insider threats from AI agents have to be collusion aware. Like you have to spend time thinking about, could the AIs break this if they were trying to collude against us? And then I feel moderately good about the prospects for, at the capability levels we're talking about, mitigating these risks if you're thinking about collusion. I'm just pretty worried that when I talk to the people at the AI companies, they're not really like prepping for handling the collusion. And that's like why I bother giving this talk.
The thing that you're saying is not going to work is like prompting them differently because you're assuming that whatever prompt you give them under the hood, they're still colluding.
Yeah, that's definitely one thing I'm assuming. Okay, cool. Let's go through the specific version of the argument, all right? So before I give a heuristic argument, which was like, this insider threat stuff is pretty different in how, like, the AI situation is pretty different from the human situation. It seems like people don't handle the human situation in a way that would, like, naively imply the AI thing is promising because the AI thing seems harder in some important ways. But you might not believe me. You might say, like, okay, Buck, what are the specific examples of things we're going to want the AIs to do where it seems really hard to use security measures to make it be okay? So to argue this, I'm going to say that lots of the value of powerful AIs comes from tasks such that, and this has like 3 layers of nested quantifiers, which is kind of unfortunate, but tasks such that you can't choose AI affordances such that the AIs can do their jobs efficiently and the AIs can't cause catastrophes. Does this make sense? So we're going to have to repeatedly do the following mental move. I'm going to name a task, and then I'm going to say, you can't name AI affordances without me being able to say that either the AIs couldn't do their jobs properly or the AIs could cause a catastrophe with this. Now, this is like enough nested quantifiers that it's like a huge pain, right? Because I have to like, when I want to argue with people about this, like, it's just like it requires going like pretty in depth about stuff. Yeah.
I understand it. I actually feel like you maybe said it more complicatedly than like when I just read it on the slide. Like there are important things we want AI to do, and it's hard to let them do it both efficiently and like safely.
Yeah, maybe I spoke too complicatedly. All right, domains that seem tricky to me to secure. All right, automated research. Okay, here's the one that I think is like the clearest and trickiest one that I'm going to spend the most time on. Currently, AI company employees often write arbitrary code that has access to model weights, and this is like kind of naively allows massive internal hacking, perhaps via rogue internal deployments. So how does it work when you have an AI agent writing code inside an AI company? Well, here's the basic picture. We have a user who wants you to try out like what happens if we make it so the activation function is now like x cubed plus 2 or whatever. Like they have that idea one day and they like type that into their chat GPT window or whatever, and the AI agent awakes. So the user's request goes to a server that I'm going to call a scaffold server, which is in charge of managing user like managing chats with users. Now it needs to know what it wants to like take a sequence of actions on some computer. The way this is going to work is first it's going to message the inference server with some prompt asking for some code to execute. The inference server will respond with some code to execute to the scaffold server, and then the scaffold server will execute that on some server that I'm going to call an execution server. Does that basic distinction of scaffold inference execution make sense to people? Or anyone have any questions and clarifying comments? Like this is basically the way that AI agents like already work if you like at scale. OpenAI has this product, right, where there's like a development environment in the cloud where they will like it'll do software engineering, right? And like that almost surely has an architecture basically like this. Another thing I'll note is I'm imagining that it's possible for both the scaffold and the execution server to work with internal tools like Slack and GitHub, and it's also possible for the model to directly query the internet or to run code on the execution server that can talk to the internet. Okay, does this make sense? Great. Well, what can go wrong? Well, I think this, like one simple thing that can go wrong is the model can propose some command, which then when is run on the execution server, causes the weights to go into the internet. If it has access to weights on the execution server, which it will often need, for example, if it's running fine-tuning experiments, then it can straightforwardly do this in the absence of security measures. Thoughts, comments, questions? Obviously, this one here is like very easy to address with like network security things like banning the AI agents from uploading 5 terabytes of data onto the internet. Though it's actually a little more complicated if you think the AIs will often have to interact with the outside world because they could try to like keep the weights in like little pieces and like put them out or whatever. So that's like one thing that can go wrong. Here's another example. Here's what I call a rogue internal deployment. So the AI agent writes code on the execution server, as it's supposed to be doing, where it writes itself a little rogue scaffold. So this is an agent, like an agent scaffold, that as usual like gets like prompts a model asking for actions and then executes those actions. And for inference, it runs a local inference server, making use of the weights that it has. If your AI can do this, then it is now running like as an arbitrary agent on your execution server with no particular mechanism for you to monitor what's happening. So like once this has happened, the situation is much worse than it was before, because before the only agent actions were happening through your scaffold, right? Like, and you could put any monitoring or logging that you wanted in your scaffold code. But if the AI has written its own scaffold, then you have no ability to monitor or log anything that's going on. So I think a lot of threat models that I imagine are the AI had the weights on the execution server because it was doing ML research, and you like often need access to the weights to do your ML research. It like spins itself up a little inference server, which is a totally natural thing to do. It writes itself a little AI agent, and now it has like as much time as you had given it to do like the task that this whole thing was spawned to do, to, for example, poke around for security vulnerabilities inside your data center, like from the execution server. Does this diagram make sense? We got a question from.
Yeah, like why is it like automatically like, oh, you've got like time to like poke around for like security vulnerabilities? Like how do we get to assume that?
Why do I? Well, you definitely get time. Like once you've built this, imagine that we had given the AI like we had our idea about an architecture innovation to try, and we spun up an AI agent and we gave it a budget of 3 H100 hours. So I'm like, now with this kind of scaffold, it's able to spend like 3 H100 hours in a totally unmonitored way, poking around for security vulnerabilities with us. And now it's not guaranteed that it's possible for the agent to find security vulnerabilities with those 3 hours. But I'm saying it definitely has the ability to poke around for 3 hours looking for them. Does that answer your question?
Sure, but like it's sort of like being given like a main task to do, and like maybe like as a little side as a side hustle, it can like poke around with 3 H100s.
Wait, no. So once the model launches this rogue scaffold, the originally launched agent, where like the control flow lives on the scaffold server, is still going, right? It's just that one of the programs that it ran was itself an AI agent, right? I'm basically saying like the AI agent like writes a little Claude code server, like a Claude code implementation that uses local inference on this computer it was working with, and now like that thing is going to be running even while the outer agent is also running.
Yeah, you look guilty, right? Like
Yeah.
if you give me like a task to do, and like like enough resources to do it, and I take those resources and do something else with it instead of doing the task you told me to do, you're like, oh, I'm gonna check you out now, right?
So yeah, that might be the case. You're saying like I think the version of this that I'm most compelled by is, suppose I gave you 3 H100 hours and a task that like definitely needs 3 H100 hours, and where there's no way.
If I can do it in half of one, I have 2.5 of free. Yeah, okay.
Yeah, it's just like this is really rough, right? Like if we're running 100,000 of these in parallel at 30x speed, like how many of these are you gonna have time to review? It seems to me like when I try to go through this game tree, it seems like
Yeah, you're like not totally sure that it's actually a 3, like it might be a more than 3 H100 hour task.
yeah. Okay. And also imagine the AI just like comes back and is like, man, I'm really sorry. I couldn't do it. Like, what are you gonna say? Like, it's a schemer, blow up the data center, boom. It just seems like you're just gonna have to be like, yeah, and our AIs fail sometimes at things. I fail at things sometimes.
So in this example where it's like running a local inference, the weights that it was going to need initially were like the same capacity as like the agent that it can like it's like working on the same system or a more powerful system. That's the assumption here.
That's the simplest thing to imagine.
Yeah, sure.
We actually get a lot of the same issues. If you I think you also have a version of this threat model where the AI doesn't have access to its own model weights, but instead has access to some other model weights and launches like a rogue deployment of some other model that has been fine-tuned or instructed, for example, to look for security failures.
Okay, makes sense.
Great question there. Okay. Here's another version of this that my friend Fabian at Anthropic recently pointed out to me. Even if you, yeah, like another version of this is basically like your execution server runs a rogue scaffold via using your public inference API. As in like if it had the ability to access the internet, then it can probably get some proxy that like then talks to like api.anthropic.com or whatever. And this might be very scary, as like it might be very hard to monitor your external API traffic in the same kinds of privacy destroying ways that you wanted to monitor your internal usage. And so if your AI is able to launch a scaffold that is using external API access, then it seems like it's maybe pretty hard to recover from there. Questions on that?
Wouldn't it be pretty easy to monitor for if anyone is calling during execution time, the internet to call your external API?
Sorry, you want to know whether the execution server is ever calling the external API?
Yeah.
Well, I think it's not easy. For example, suppose my computer, like I am bad at computer security. So like suppose I just leave my desktop computer totally vulnerable and with my like Claude API keys on it. From Anthropic's perspective, what's happening is the execution server is like talking to Buck's computer, which maybe they're fine with for some reason. But they have no way of knowing that what Buck's computer is doing is like making API requests to the Anthropic API.
Okay, I see.
Okay, I want to get through a couple other things here. So like, okay, can we do permissions reduction here? I think it seems pretty rough. So here's currently the way that this works. Employees at AI companies often do work using inference APIs. This is like kind of the like gold star example we have so far of reducing permissions to employees in a way that is not inconvenient for them and that reduces security issues. Like a lot of people at Anthropic, for a lot of the work that they're doing, don't actually have the Claude weights checked out locally. They just make queries to an internal copy of the API. This is way easier for us to handle in a bunch of ways. Among other things, there's no way that it ends with a copy of the model weights being somewhere we didn't know about. Yeah. Unfortunately, much of the research you do cannot be done purely with an inference API, right? So for a lot of stuff, you just actually have to have full weight access. Okay, so how could we try to like push the permissions reduction stuff here? Well, one version is one reason that AI company employees often have access to model weights is because they needed to do fine tuning or they needed to do reinforcement learning. A thing we could try to do is come up with really good fine tuning or reinforcement learning APIs and then force the employees to use those APIs instead of directly having model weights access. My guess is that this is a moderate pain in the ass, basically because it's like it's just really annoying to use other people's APIs for like fine tuning an RL. There's like things often go kind of wrong and you like don't have the diagnostic tools that you wanted, and you often can't hook in to modify the things you wanted. The Tinker API, which is made by Thinking Machines and came out last week, is like an interesting example of another strategy you could use for permissions reduction that I think is like kind of promising, that I don't want to get into it right now. Okay, here's another important difference, or like another thing which seems hard to secure, is it seems reasonably likely that at this point, the AIs will be writing lots and lots of security critical infrastructure. I'll just like to quickly name a couple of reasons to expect this. AI and human labor is going to be very different, and this will incentivize massive infrastructure changes. It might be the case that rewriting your security critical infrastructure will get you big performance improvements. The AI company might want to build a bunch of new security critical infrastructure really quickly because their previous infrastructure was not secure enough. And finally, it's possible that you'll want to adopt a bunch of new hardware, and this will require you to modify security critical code. So this was me naming another thing we want to do with the AIs that seems very hard to do with permissions restrictions. I'm saying if we want the AIs to write code that is blatantly security critical, we will naturally end up with them writing lots and lots of this code. And I don't like, there's just kind of like no way to like sandbox it such that this code is not security critical because it is inherently security critical. A couple more of these. One of the big things that you're going to want to do with your AIs is generate like 20 terabytes of training data for your AIs after that. This seems like naively pretty terrifying. Like, I'm really worried that your AIs will take advantage of the fact that you've asked them to build 20 terabytes of training data with like a bunch of like bespoke diverse tasks and make it so that that training data is subtly poisoned such that it'll cause future AIs to either be aligned with them or perhaps just obey them when they see a particular string. I have no idea how you would resolve this, or like it's possible this is easy to resolve somehow. Currently, this seems like a difficult technical problem that deserves more investigation. I think it's basically a lose condition if some of your AIs have like implanted secret loyalties into future AIs. Yeah, take a hand.
Isn't this like sort of like naively, like the way you might like want to like prevent this is by having like a separate AI review the training data that's not like a totally like yeah, a totally separate AI. Like and you're saying you can't confirm that it's a non like it's not like scheming with it.
Yeah, so I've been imagining that you have your most capable AI that, by assumption, on our colored slide, is like coherently plotting against you. And also you have some dumber AIs that you are sure are not plotting against you. We can always try to use dumber AIs to review the process or like the things that were produced, but then we're trying to rely on like dumber AIs to understand what's going on with stronger AIs. We can maybe make something like that work. I think it's kind of non-trivial. The thesis that I was trying to argue for here is just that if we don't try to adopt things that are not part of the current human insider threat playbook, like if we just try to do permissions reduction, we're not going to be able to prevent all the problems from occurring. All right. Well, I'm just going to name a couple other things here. Obviously, something which seems extremely hard to prevent with permissions reduction is research sabotage. You ask your AIs to investigate questions, and they just come back with complete lies about the answers to those questions. I don't know what security techniques you could possibly implement that would resolve this issue. Another one is the sabotage of external artifacts that I mentioned earlier. If you're having your AIs design and build like the code for robots that are going to have bombs strapped to them and be widely deployed in the outside world, again, just like fundamentally, I don't know what you can do with permissions reduction to mitigate this risk. Okay, cool. Well, that's basically my take. I'm like, yeah, what do I think you should do instead? Well, you should do some stuff that relies on access to your cheap, dumber AIs, and then you're going to have to be kind of smart about the fact that they are dumber than the AIs that you were scared about. And then you're also going to want to do stuff that relies on the fact that the AIs might have trouble coordinating because they don't have free communication with each other. Like the untrusted AIs, even if they want to coordinate with each other, might have trouble pulling that off. Bashcontrol.com, which is our like last paper on this, is kind of the state of the art on the techniques that we have for this. Yeah, and hopefully we'll do better work in the future. What I do with my life, I continue to do research on these techniques under the assumption that permission reduction does not solve all our issues, and then I argue with AI companies on these topics. Great. That's my content. Thanks very much. We have time for some questions.
I think earlier in the presentation you said that it's only 35% likely that there'll be some kind of scheming event that you've described here. I'm curious
At this
about
level of capability, yeah.
why that is, and if as far as the research to date on like scheming, and there's like some evidence that models can scheme like to fake alignment or sandbag themselves. Like if you find that scary or not scary, like where it is now.
Yeah, so I mean, I was on the alignment faking paper, and I do think that that's concerning stuff. That's how I get like up to 35. Or in some sense, it's like, yeah, I think 35% is like a pretty high number compared to some other numbers like 2% or 0%. I think that the evidence we've seen so far isn't extremely compelling. I feel like I haven't really updated on empirical evidence very much about like the scheming. Really, it just feels to me like we have some conceptual arguments for why you might expect your AIs to eventually scheme. The evidence has come out like sort of interestingly in a way that like it seems like it's like consistent with future AIs scheming, but like not wildly strong evidence for that. Is kind of where I'm at.
I still want to talk about assumptions. Like, do you think it's likely that we will end up at some moment some models suddenly become like super scheming, or like we'll see some gradations and maybe we'll do some interventions? To me it feels much more likely that we'll see like some sparks of coordination and that we start like intervening and so on.
Yeah, if I had to guess how this actually goes, it's something like conditional on this superhuman coder scheming. My guess as to what happens is the AIs seem schemier and schemier. Like currently, like they seem a little bit schemy. And there's some kind of suspicious and concerning results, like the fact that, Sonnet 4.5, when it's in alignment tests, says I'm in an alignment eval like for like 80% of the time or whatever it is, which I think is like kind of concerning as like a fact. I think that as like if the scheming is eventually a huge deal, it seems reasonably likely the way this goes that the AIs seem schemier and schemier, and we get like more and more scared. But like for a while, we're able to rely on the fact that the AIs, when we evaluate their capabilities, are clearly not able to hold their shit together for long enough to engage in like careful plotting against us, and so we're like not that scared by it. And then eventually, the AIs continue to be kind of like a little weirdly schemy looking, perhaps less schemy looking, but now we think they're capable enough that they really might be plotting against us. So that's the situation I think is like most likely. I mean, it's also pretty plausible that the models that we're talking about here, like I will think they are probably scheming. Like I think it's reasonably likely that like the most with it staff at the AI company are like, yeah, this model is like probably a schemer, but they like can't convince people at the AI company to like do something insanely expensive, like throw away the model or like complain to like what are they going to do? Like you spent like so much money on this model, you like kind of have to deploy it is what they're going to say. And like the evidence is going to be like mediocre enough that if it's like the CEO's number one job to downplay these concerns internally, they'll just succeed.
So I think this is kind of related to my question before, and this is just because I work in like such a parallel universe of like diffusion models versus like LLMs, but like for my like for anything that we do, the models that we're using to assist our research are just qualitatively different than what we're developing. And is that just like an easier security landscape for your like assessment here? I mean, obviously, like, you could have yeah, I guess I just like I struggle to imagine the world where like the weight copying kind of comes from the same model itself, just because like everything I work on is like using an LLM to like make diffusion better. And obviously, if you're working on making LLMs better with LLMs or some general agent model, does that make sense?
Yeah, so I think a lot of the work on AI R&D is going to be making AIs be better at like general agent stuff, especially AI R&D. So yeah, I think I spend most of my effort worrying about the situation where the AIs are working on AIs that have similar modalities, similar goals. The example with the like sabotage of the robot armies or whatever is like an example of the other kind where I'm like, it seems really like the robot soldiers are not going to be contributing very much to the soldier R&D, but like it's still bad to sabotage them.
Yep.
Great. We're at time. Thanks, everyone.